So we filled in the top part of the flowchart, which one of the key pieces of is to make sure you put your page numbers on this so that you can use this to help you refer to your exam notes packet and know what type of formulas you need to use, etc. So now we have to kind of remind ourselves of all the little bits and bobs regarding hypothesis tests that we might have forgotten. So what are some words that cue that you're going to do a hypothesis test? So of course, there's the standard conduct a hypothesis test. It's kind of a sign, right? So if they tell you to conduct a hypothesis test, that generally is it. But you can also look for level of significance. If there's a level of significance given, that means you're doing a hypothesis test. Can you conclude that? Right? If it's asking for a conclusion, that means that you have to run the test to be able to draw that conclusion. All right, now what about type 1 and type 2 errors? We have seen this before. They have an inverse relationship, which means that if alpha goes up, beta will go down, or if alpha goes down, beta goes up. Which should make you wonder, wait a second, what are alpha and beta? Where did those symbols come from? Alpha is the probability of a type 1 error. Beta is the probability of a type 2 error. So I think type 1 and type 2s are great. I personally like saying them that way, but I know that a lot of us think about it in terms of medical screening tests. So this is the probability of a false positive in medical screening. Right? The medical test says you have the disease, but you don't. Right? That's a false positive. And this is the probability of a false negative in medical screening. I don't generally use that terminology outside of things like virus detection, and that could be virus detection for a computer as well as a person or an animal, that kind of thing. But so diseases, that kind of thing. But for things like manufacturing problems, the false positive, false negative doesn't quite work as well in terms of language. So that's why it's helpful to know type 1 and type 2 errors. Now, statistical significance, that word, when you see statistical significance means you get to reject the null hypothesis. Right? That will be statistically significant. That's not necessarily practical significance, but that's statistical significance. And of course, we do that when our p-value is lower than our alpha, our level of significance. Practical significance, let me give that its own color. Practical significance is a judgment call based on context. So you need to be able to have that context so that you can compare the sample statistics to the null hypothesis and make a judgment about whether they are important. So you compare your sample statistics, if you will, to the null hypothesis, and you're making kind of a judgment about whether or not is the difference important, right, in real life. And that's beyond our scope, right? So that's weird because, what's important to one person might not be important to another, but that's the kind of question that we're asking. That's the kind of judgment call we're trying to make here. So we are not going to be doing much of that, of course, because that's beyond our ability to do in a basic statistics course. But suffice to say, that's what happens with the statistics that you're learning about, when we reject H0, was that really significant in real life? That's happening in economics classes and business classes and nursing classes and that kind of thing, right? They have to look at the data and decide, well, but would it help in real life? All right, now a few more things about p-value, since p-value is very, very important. So p-value is the probability of a fluke. But what's a fluke? It's the chances, it's the probability of getting the sample statistics that we got by random chance. So it's the probability of getting the sample statistics by random chance if the null hypothesis was true. Right? So what were the chances of getting what you got? If the null hypothesis was true, what were the chances of getting the result that we got? All right, and remember, when the p-value is low, we reject HO, the zero hypothesis, the null hypothesis. We always want, because we're always trying to reject that null, we always want our p-values to be low. The lower, the better. Now, what does better mean? Better means more significant. So I should have probably written that differently. So that means more significant. If your p-value is lower, it is more significant. It is better because you're trying to reject the null hypothesis. And by low, what do we mean? We mean the p-value lower than the alpha. That's what low means. Now, one other thing to keep in mind here. So let me make a note. The p-value is the area in the tails. Right? So if you look at a graph, Z curve or T curve, either way, 0 is in the middle. And the p-value is either the left tail or the right tail, or both, right? It could be both tails. If it's a two-tailed test, it could be just the left, just the right. It depends on what we're doing. So I'll assume a two-tailed test. So over here I have either negative z0 or I have negative t0, depending on z0, t0, right? Or. So what does this mean for us, right? If we want our p-value to be low, we want this area in the tails to be small. That will happen when our z-scores are farther out, or our t-scores, right? So the farther your z0 or t0 is from the mean, the lower the p-value is going to be. All right, so let's make a note. And the mean is always 0 for both a z-curve and a t-curve, right? So the farther they are from 0, the smaller the p-value will be. One other thing that I just thought of, Z0, T0, what am I talking about there? So if you look at means tests, they use T. These are T curves, right, which have a particular degrees of freedom. They look a lot like the Z curve, but they're not the same, right? So T curves, T0. So it could be left-tailed, right-tailed, or two-tailed. If you look at a test for proportions, right, test for mean uses T0, test for proportions uses Z0. So when you think back up to the segmenting that I did up here, proportions, they use a test stat of Z0, right? Could be positive, could be negative, right? But in general, Z0, right? There is a chance for a plus or minus if you're using a two-tailed test, right? Whereas when you're using a means, down here, means use a test stat of T0. So proportion problems use the Z curve, means problems use the T curve. And one last thing I thought of while I was looking here, I want to make sure everybody remembers how to find Q's. So remember, Q is 1 minus P, right? They are complements of each other. So if you want Q0, you take 1 minus P0. If you want Q1 hat, you take 1 minus P1 hat, right? Q and P are complements of each other. That's how we find those Q values for those particular formulas. And while I'm on the subject, let's also remember that P hat is always X over N. We learned that in chapter 6 technically, but it's still coming in handy for us even at this late stage.